Before we begin, I want to thank someone. If you've ever watched 3 Billion 1 Brand, you already know how beautiful mathematics can actually be. Grant Sanderson completely changed the way of millions of people, including me, see mathematics. He showed us that equations aren't just symbols, they are ideas you can actually see. This series is inspired by that vision, but before we can actually continue, allow me to introduce myself. My name is Osuolale. I'm a computer science student from the southern part of Nigeria. I'm basically a Yoruba boy. I also have a very deep passion for mathematics, physics, and understanding of how our universe works. And for as long as I can remember, I've been fascinated by one simple question. Why? Why does equation work? Why does nature speak the language of mathematics? Why can an handful of symbols describe an entire universe? Those questions eventually became Curionium. This channel isn't about memorizing formulas, it's about seeing mathematics the way nature sees it. So, whether you're a student or someone who is simply curious, or you are one of many people who discover the beauty of mathematics through 3B1 Brand, I hope you feel at home here. Because this is Curionium, and here we don't start with formulas, we start with questions. We'll talk about mathematics piece by piece and rebuild it from intuition so that by the time we reach the equations, they don't feel like something to memorize. They feel inevitable. So today we're going to begin with a question almost nobody asks. Not what is linear algebra, but why did humanity invent it in the first place? Imagine living thousands of years ago. Mathematics already existed. You could count ships, measure land, build pyramids, predict the seasons, describe shapes. Numbers seems powerful until nature presented a problem. Suppose you stand outside on a windy day. Someone asks, how strong is the wind? You answer, 20 km per hour. But that is not enough, because the wind isn't just moving. It is moving east, or west, or northeast. Now imagine you're launching a rocket or steering a ship across the ocean, or calculating the force pulling the moon around the earth. A single number no longer tells the whole story. Nature keeps giving us things that doesn't just have size. They also have direction, and suddenly the mathematics humanity had built thousands of years wasn't enough anymore. Not because it was wrong, but because reality has become richer than the language we were using to describe it. We need a new kind of mathematics. Instead of describing how much, what if mathematics could also describe which way? Instead of treating motion, force, light, and velocity as separate ideas, what if they all spoke the same language? That simple question changed everything. Mathematicians began developing a way to describe quantities that have both magnitude and direction. Not just numbers, but arrows. Soon, those arrows could be added together, scaled, rotated, combined, and eventually entire space could be stretched, rotated, reflected, and transformed. This becomes the beginning of what we now call the linear algebra, not a collection of mysterious matrices, not pages of calculation, but a language for describing space itself. Today, that language powers computer graphics, artificial intelligence, robotics, quantum mechanics, GPS, engineering, and almost every modern technology that interacts with the physical world. Linear algebra wasn't invented because mathematics wanted another branch of mathematics. It was invented because reality demanded a better way to describe itself. And in the next episode, we're going to begin with the simplest question of all. What is a vector? Really?